Just to make sure you guys know, if you check your Moodle site and stuff, we're finishing up section 1.5 and moving on into 2.1 today. And if you go check on your quiz stuff and things that are due, I guess for me, it depends on how much stuff you've done. I've got to get quiz 4 done by today, and then due in a week, the stuff we've been working on, section 1.5, and quiz 5 on that, and then quiz 6, which will be the stuff on 2.1. So this stuff will be moving kind of quickly here. So pay attention to all your homework sets you've got to do. Also, to let you guys know that, in terms of your test, and when we get to the test and the like, I'm going to do a traditional homework set you guys are going to have to do. So this is how the test is going to work. Before the test, you're going to have a traditional homework. I'm going to post on our Moodle site a standard homework. You're going to print it out, show all your work, do the problems like I do in class, just right off the notes type thing here. Is also off our software system. And then for the test, you're going to have what we call a web test. This web test is going to be questions that you're going to answer on the computer system, and then we're going to have a traditional test in class. So you're going to have kind of a homework set and an outside Hawks system test on the computer, an outside homework set that I'm making up personally, and my homework set is going to well represent what the test is going to look like. So they're going to be very close. So we're trying to set you guys up so you guys will be well prepared for the test when you do the homework, the web test, and then you're ready for the traditional test. Yes, ma'am?
Do the web test and the physical test both count for test grades?
No, the web test is actually considered part of your homework grade. It's a special homework grade that I'm putting with the homework test. We're only going to have 3 of them just before each test. And then the test itself, that stands alone. When I give you test 1, that's your big 30%. That's test 1. That's 1/3 of the whole thing. Yeah, my homeworks are like practice tests. They're really signaling to you what kind of questions, how I'm going to word things like that on the test. All right, so we're in section 1.5, and we've been working on polynomials, and we've done kind of a lot here on this type of thing, but it is a big section here. So everything's set up here. There we go. And so here's my polynomials from section 1.1. Let's pick up where we left off. We added, subtracted, multiplied polynomials, and now the next thing we're going to do, we're going to pick it up with doing the factoring of polynomials. Now remember, the main idea behind factoring is to pull out what's in common. Pull out what's in common. Now we got the anti-fold method when they get a little larger and stuff like that, but still the main idea is to pull out what's in common. So let's take a look at this first problem right here under the common factoring methods. I've got 8x squared times y minus 4xy. This is a classic binomial, and I want to factor it. Now, what's the purpose in factoring? Factoring turns adding and subtracting into multiplying. And only through strict multiplication division do things cancel. That's why it's important. So, what's in common on 8x squared times y minus 4 times xy? Well, look at your coefficients. Between 8 and 4, what's in common? 4. I'm going to factor out the 4. I got x squared y and an xy. Between the x squared and x, what's in common? They both have x to the first power. And a y and a y, they both have a y in common. So when I pull out a 4xy, what am I left with? Well, when I pull a 4 out of an 8, I'm left with a 2. When I pull an x out of an x squared, I'm left with x. And I pull the y out, it's completely gone. Minus, when I pulled out the 4xy out of a 4xy, what is left for placement that's always there? 1. When you pull everything out, you're always left with a 1. It's not 0, don't just discount it, 1. And to double check yourself, You can always go back and distribute, and you should get back right where you started from. But the whole purpose of factoring is to turn things into multiplication. Because under multiplication division, that's when things cancel. So I have to factor it first. So this factors. Now the next one is no doubt something that you're quite familiar with, because I know in high school the goal was to beat you to death with this kind of stuff. And that's called, when you have trinomials, 3 terms, and then factoring 3 terms, the anti-full method. So these are pretty straightforward because each one of these guys has a leading coefficient of 1. It makes it a little bit easier until I start changing the leading coefficient. But this one has a leading coefficient of 1. So look at this one, x squared plus x minus 6, and I want to factor it. Factoring is this anti-full thing here. And so what times what is x squared? X and x, so I put x and x in the first spot. Now here comes the game. What times what is 6? What are the factors of 6? Now, I got lots of factors of 6. It's 1 and 6 and 2 and 3. But which one of these factors is such that when I multiply, I'm going to get negative 6, but when I add them, I should get a 1. But because there's a minus here, I'm not actually going to add them, I'm going to subtract them. If this was a plus sign, I would add my factors to get the middle term. But when it's a minus sign, I'm going to subtract my factors to get the middle term. And we're talking about the middle coefficient here. I got a 1. Which one do I use if I want to take the difference and I'm going to get 1? The 2 and 3. Because it's a minus, when you have a negative, the signs are going to be one's positive, one is negative. Because the middle term is plus, that means I want the bigger number to be plus. Which one is bigger, 2 or 3? 3 is bigger, so that'll be the plus, and that means the minus is going to go on the 2. So there's a lot of things going on here, but it's more of a detective work on how I'm trying to figure out how to factor this stuff. But now, here's the big deal. You can always double check yourself with this stuff. So if I got this problem and I'm not 100% sure because I could have made a careless error, what can I do to get this answer? Pull it back out. X times x is x squared. X times 3, that's 3x. Minus 2 times x, that's minus 2x. What's 3x minus 2x? 1x, so that checked out. And minus 2 times 3 is minus 6. So all the terms checked out. But it's that outer inner that has to combine to get that 1x. So this factors. And again, what I did was I took x squared plus x minus 6 and I turned it into multiplication. Very important property because that's where things start to cancel out. What about this next one? Problem number 23. X squared plus 4x plus 4. How does this guy going to factor? Well, let's see here. It's a trinomial, 3 terms, so I'm going to do my anti-full. Turn it into 2 terms times 2 terms. What times what is x squared? Clearly x and x. But what times what is 4? Well, I got options on 4 is 4 and 1 and 2 times 2. But because it's a plus, I want to add the factors to make the middle term. Which terms, when I add them together, I'm going to get 4. 2 and 2. So this will be 2 and 2. And because this term's a plus, that means they're going to have the same sign. And because the middle term's a plus, that's basically telling what the signs have to be. The signs have to be plus and plus. And of course, when it comes to factoring, I can always double check my answer by pulling it back out. X times x is x squared. X times 2 is 2x. 2 times x is another 2x, and 2x plus 2x makes up the 4x. And then 2 times 2 is 4. So it pulls back out. What about the next guy? X squared plus 5x minus 24. Let's try to factor that guy. Again, x squared, coefficient 1, you put the x and x here. But now, this is where it starts getting messy when you get these big numbers that have a large number of factors. What are the factors of 24? Let's see here. 1 and 24. Let's see here. 2 and 12. 3 and 8. 4 and 6. Any more? I think I got them all covered here. So there's lots of factors. So which one is it going to be? Well, look at your signs. This is a minus 24. That means I want a factor to have a difference. That'll be a minus, so the difference needs to be 5. Which one of these guys has a difference of 5? 3 and 8. 3 and 8. And when it's a minus, that means one term is going to be positive, one term is going to be negative. Which one's going to be which? Look at the middle term. Since the middle term is plus, that means I want the bigger number to be plus. Which one's bigger? The 8's bigger, so it's going to be the plus. That means the minus has got to go in the 3. And then I can double check myself by folding it back out just to make sure I didn't screw it up. Does that make sense? So it's a game on working this stuff. But it's a very important game because you know where we're going to be going with this stuff. We're going to be sitting there taking expressions and trying to simplify them. But to simplify a fraction, you have to have strict multiplication division, so things are going to cancel. This factoring turns things into multiplication division. Look at the next problem. X squared plus 6x plus 5. Again, I'm going to trinomial, 3 terms. I'm going to anti-fold it here. X. Well, 5, that's nice. I only got one option with 5. How does 5 factor? 1 times 5. And you'll notice that it's a plus, so she's got to add up to be the middle term, which is a 6, which works. So this has got to be a 5 and a 1. And because the last terms are positive and the middle terms are positive, they're both going to be positive. Does that make sense? But it's the next ones that actually are time consuming. It's when the leading coefficient is not 1. So you actually got to figure out lots of different options and do a bunch of stuff in your head. You can write them out too, but you're going to kill some trees doing it. So here we go. 6x squared plus x minus 2. I'm going to do the anti-fold, but this is the coefficient of the leading coefficient is not a 1. So I've got to factor 6x squared. How does 6x squared going to factor? Well, 6x times 1x. I also have an option of 3x times 2x. And then you've got to factor the last coefficient, which is a 2. What are the factors of 2? 2 times 1. Now, I've got to do, basically in my head or write it out, I've got to figure out, folding this thing out, which one is actually going to give me the middle term. Okay? The sign operation still works. This is a minus. You with me? Which means I want the difference of this anti-folding stuff to give me the middle term of 1x. Which one is going to give me a 1x? Well, let's see here. All right, I believe if I do this, I multiply 3x times 1, that's 3x, and I multiply the 2x times 2, that's 4x. What's the difference in 3x and 4x? 1x, and that's what I want. So I'm thinking this is it. But if I do this other one, just to show you, if I had 6x and 1x versus 1 and 2 here, 6x times 1 is 6x. 1x times 2x times 2 is 1x times 2 is 2x. So 6x and 2x, the difference of that would be 4x. But that's not what my middle term is, so I know I don't want to do it with those factors. So I'm going to go with the 3x and the 2x, but remember you're folding it out. I wanted to multiply the 3 times the 1, so 3 has to multiply times the 1, and I wanted to multiply the 2x times the 2, so in my full, this is my outer inner stuff. Now I got to figure out what the signs are. That's a minus, which tells me one of them's positive, one of them's negative. But I want the bigger number to be positive. What gave me the bigger number when I fold? Well, I have the 3x times 1, that's 3x. And the 2x times the 2 times the 2x is 4x. The 4x is bigger, so I want the 2 to be plus and the minus to be on the 1. So in other words, I am doing a lot of different kind of manipulations here. And it is real easy to screw this stuff up. So, what should I do right here at the end? Now these other ones with the leading coefficient 1s, okay, I kind of cheated because I could actually fold a lot of this stuff in my head. But I'm not so confident. I'm way less confident when I have the leading coefficients not 1. I always just double check myself, come over here and go, all right, 3x times 2x is 6x squared. 3x times minus 1 is minus 3x. 2x times 2 times 2x is that 4x. And then 2 times negative 1 is minus 2. That's 6x squared. Minus 3x plus 4x is plus x minus 2. And it checks to what the original question was. So I know I got it right. Always check your answer with this anti-folding stuff. It's real easy to make a careless error. Take a look at the next one. 8x squared plus 14x minus 15. Okay? So, what are the factors of 8x squared? I got 8x and x, 4x and 2x. What are the factors of 15? 15 times 1 and 5 times 3. So, several couple options for the leading coefficient, couple options for the constant. So here's my anti-full thing here. All right, so which one am I going to use? Well, it's a minus again, which means I want to subtract the outer inner parts to get a middle term of a positive 14, which is what is going to give me a positive 14. Well, here I go, process of elimination. 8x times 15, well, that's just huge. 8 times 15 is a big number of 120. 1 times x is x. That's 120 minus x is 119. That's not it. So maybe the 8x times 1 and the x times the 15. What's the difference between 15x and 8x? 7x. My middle term's not a 7, so those aren't my combinations. So I keep looking. What about the 8x and x times the 5 and 3? Well, 8 times 5 is 40. That's 40x and 3x. Difference of 40 and 3 is 37. That's not close to 14, so that's not it. What about the other one? 8x times 3, how much is that? 24. X times 5 is 5x. What's the difference between 24 and 5? 19. So 14, so that's not it. So maybe you should go down here and try this one. And that's my goal here, was to show you that, I mean, you basically are running all the different options you can have in this stuff. But one of them's going to work. Let's see here. 4x times 15, that's like 60x. 2x, that'll be 58x. That's not my middle term. 4x times 1 is 4x. 2 times 15 is 30. Difference of 30 and 4 is 26. That's not it. But it's probably going to be these last two. That's the story of my life. It's always the last one I get to. All right, 4x and 2x. Let's see here. 4x times 5, that's 20. And 2x times 3, what's the difference between 20 and 6? Winner. All right, so that's what I'm going to go with. 4x and 2x. I want to multiply the 4 times the 5. So remember your 4. First, your first outer 4x. I want the 5 to go here, so it's the 4 times the 5. Then I'm going to do the 2x times the 3. Now I got to worry about the signs. It's a minus, which means you're going to have opposite signs. But because the middle term is positive, I want the bigger of my outer inner folding to be the positive term. So the 4x times the 5, that gave me the what? 20. And the 3 times the 2x gave me 6x. I wanted the bigger number to be positive. So 4x times the 5, I want the 5 to be positive. And that makes the 3 going to be the minus. And of course, I'm going to check this thing out. Take your time on this stuff because it's real easy to screw up. 4x times 2x is 6x, 8x, that's embarrassing. 8x squared, 4x times 2x is 8x squared. 4x times 5 is plus 20x. Minus 3 times 2x is minus 6x. And minus 3 times 5 is minus 15. Putting together my middle term, that's 8x squared plus 14x minus 15. And it checks. So I factored it correctly. This is my solution. My point is that when you've got leading coefficients that aren't x squared, don't be so confident. Double check it out, pull it out. And basically, you're doing first, outer, inner, last in your head. But there's going to be some very special factoring that you need to focus on. And here is one of them. It is called the difference of squares. Now, the sum of squares can't factor, so I'm going to actually write that up here for your benefit. A squared plus b squared does not factor. This is called a difference of squares. A squared minus b squared. And this means that the first term is being squared minus the second term being squared, and it factors into a minus b times a plus b. So, take a look at this guy here. X squared minus 9. you could rewrite that as x squared minus what exactly is 9? 3 squared. So your a is x and your b is 9. So how does this going to factor? X minus 3 times x plus 3. Difference of squares. What about 4x squared minus 1? Rewriting them as a difference of squares. What is 4x squared? Could you break that down into something quantity squared? 2x quantity squared. 2 squared is 4, x squared is x squared. Minus 1, that's easy to turn into a square. 1 is 1 squared. So here your a is going to be 2x and your b is going to be 1. So how's this thing going to factor? 2x minus 1 times 2x plus 1. Excellent. But notice how I wrote these guys as who's being squared minus the who's being squared. That's helpful. I mean, I know a lot of these problems you can actually do in your head, but when you get down to something like this, y to the fourth minus z squared minus x squared. That is a difference of squares, but what are the actual squares themselves? What exactly is y to the fourth in terms of squares? Y squared squared. Minus, what exactly is z squared times x squared? Well, in strict multiplication division, you could factor out the square. That's z times x squared. So your a is y squared, and your b part is zx. So how is this going to factor? Y squared minus zx times x squared plus zx. A very important way of factoring. Difference of squares. Okay? Now, these formulas right here, we actually fold them out, but they want the difference in sum of cubes. So here is a little typo that we just found on my notes. So don't worry, next semester we'll fix it. All right, but this is not the sum difference of cubes and the sum of cubes formula here. Let me show you what the difference in sum of cubes are. Here it is. Difference of cubes. A cubed minus b cubed. How does that factor? That factors into a minus b times a squared plus ab plus b squared. And this trinomial actually does not factor. This is the best you can do on it. And the other one is the sum of cubes. Sum of cubes does factor. A cubed plus b cubed actually factors into a plus b times a squared minus ab plus b squared. All right, what do we expect? You to have it memorized. Of course, it's math class. Memorize everything. But what I've got here is I actually have one of them memorized, and I just know the pattern of it, so I got the other one for free. Let me show you the pattern. A cubed minus b cubed. I'm trying to factor it, so it's going to be a minus b. The same thing, except without the cubes. Now look at the rest of it. It is a squared, but it's going to be the opposite sign of what's inside here, plus ab. These two guys multiply together, plus a b squared. It's always plus b squared. Look at this guy. Compare. A cubed plus b cubed will be a plus b, the same sign, with an a squared, but the sign of the middle guy is always opposite the sign that's in the middle here. That'll be minus ab plus a b squared. So these are the formulas that you need to know. So let's take a look at it. Let me slide it up here and blow it up slightly so you guys can see this. All right. So what exactly, how does x cubed plus 8z cubed factor? Well, first off, you got to recognize it as a sum of cubes. X cubed is clearly x quantity cubed. But what exactly is 8? Break down 8 for me. 2 cubed. 2 times 2 times 2, right? So this would be parentheses 2z quantity cubed. It is a sum of cubes. So according to this formula here, this would be equal to x plus 2z, a plus b, times, what's the wonderful use of parentheses here? X squared minus x times 2z, a squared minus ab plus b, which is 2z, quantity squared, close parentheses. I'm literally plugging it into the formula. Let me just show you. This is a cubed plus b cubed. This is equal to a plus b times a squared minus ab plus b squared. I just put parentheses here because I want to clean it up. Now how does this clean up? This will be x plus 2z times x quantity squared is pretty much just x squared. How would you clean up minus x times 2z? Minus 2xz, but most important, plus. How does 2x quantity squared clean up? What are you going to get there? Oh, sorry, 2z squared quantity squared. What is that? 4z squared. There is my final answer. And remember, this is a type of trinomial that will not factor, so there's no reason to waste your time on trying to get it to factor. Does that make sense? All right. Take a look at the next one. 125 x cubed minus 1. You need to recognize this as the difference of cubes. What exactly is 125? Well, let's go through the cubes you're supposed to know. What's 1 cubed? 1. What's 2 cubed? What's 3 cubed? 27. What's 4 cubed? Keep working on it. 64. Good. 4 cubed is 64. All right, here we go. What's 5 cubed? 125. That's pretty much the numbers we'll use. So 5 cubed is 125. So this would be written as 5x quantity cubed minus, how can you write 1 as a cube? Very much 1 cube. 1 cube is 1. Here is your a, here is your b. I'm going to plug it into the a cubed minus b cubed formula, which is a minus b times a squared plus ab plus b squared. This is my formula. I'm just recopying this thing up here for you guys. So I'm going to show you, I'm going to plug this literally right into this formula. A is 5x minus b is 1 times a, which is 5x quantity squared, watch that parentheses, plus a, which is 5x times b, which is 1, plus b, which is 1 squared. And now I'm going to clean up all the stuff inside. So this will be factoring into 5x minus 1 times, what is 5x quantity squared? 5x times 5x is 25x squared. What is 5x times 1? 5x plus 1 squared is 1, and there's my solution. And the trinomial part will not factor, don't even waste your time. Does that make sense? Did I lose you anywhere? All right, but these formulas, and again, it was a typo on my sheet. These were actually the falling out of a plus b cubed and a minus b cubed. I wanted the difference in sum of cubes, so these are the forms you're supposed to have memorized. Just like you're supposed to have memorized the famous difference of squares. We beat you guys to death on difference of squares. A squared minus b squared equals a minus b times a plus b stuff. Okay. The next problem here is another technique called factor by grouping. Now, let me understand what's been going on here in terms of factoring. I'm breaking this up into different kinds of problems. When you had 2 or 3 or 4 or however many terms, the main idea behind factoring is pull out what's in common, turn things into multiplication. But then, all of a sudden we started getting into bigger polynomials, trinomials. We did the anti-full method, okay? Then we did the binomials, went down a little bit, but this major formulas, difference of squares and the difference of cubes and sum of cubes. But now, what kind of problem do I have? How many terms do I have in this thing? 4. This is called factor by grouping. Factor by grouping. It is a trick. It doesn't always work, but it's the best way to factor 4-term polynomial. Factor by grouping is this. You take your polynomial, which is x cubed plus 2x squared plus 2x plus 4. It's a game. You group together the first two guys, and you group together the last two guys. Okay? X cubed plus 2x squared. The first two guys. What do you have in common? Factor just the first two guys out. X squared. If I take out an x squared, you would be left with, take an x squared out of an x cubed, you got an x. Take an x squared out of a 2x squared, you're left with the plus 2. Now plus, keep the sign in the middle, factor the last two terms, 2x plus 4. What do you got in common there? 2. Factor out the 2. What are you left with? X plus 2. Now here's the trick on factor by grouping. When you factor out the first two terms and factor out the second two terms, there should be a common factor between those two sets. You went from 4 terms down to 2 terms. Look at these two things. What do they both have in common? What do they got both of them in them? X plus 2. Now you're treating it as a term plus a term where they have an x plus 2 in common. So this will be equal to, factor out the x plus 2 because that's in common. And you're left with, I'm putting a bracket, you don't have to write brackets, but I'm trying to emphasize I'm factoring out of this stuff here. I'm left with an x squared on the first term plus a 2 on the second term. And that's how it factors. And here's the deal. I turn this big polynomial that's being added and subtracted into two things being multiplied together. And I don't know what happened there. That's an x. Okay, x plus 2. Sorry about that. The x squared's there. So it's x plus 2 times x squared plus 2. Does that make sense? Because I factored out the x plus 2's in common. All right, so let's do this factor by grouping on this guy. Look at the first two terms and last two terms. Now remember this. When you're factoring, the first thing you should always do is see if there's anything in common. Well, on these problems, I don't have anything in common between an x cubed, a 3x squared, a 5x, and a 15. There's no term in common. The next thing that I notice, I've got 4 terms. With 4-term polynomials, I'm going to do factor by grouping. So group the first two guys together. X cubed plus 3x squared, what you got in common? You can factor out an x squared, leaving you with an x plus 3. What about this one? Minus 5x minus 15, what do you got in common? You got the 5 in common, but you also have a negative in common. They both have negatives, right? So I can factor out the negative and the 5. Take out a negative 5. What are you left with? When you take a negative 5 out of a negative 5x, what are you left with? X. What are you left with when you take a negative 5 out of a negative 15? Plus 3. And what a surprise. You know it's a factor by grouping problem when you see you have the same factor in both of the first set term and the second set term. Now continue factoring. What do I have in common? Is between these two terms now is the x plus 3. And I am left with, parentheses, when I factor the x plus 3 out of the x squared times x plus 3 term, I'm left with x squared. When I factor the x plus 3 out of the second term, what am I left with? Minus 5. 5 is not a perfect square. It's 5. It's kind of prime there. So typically I would try to do difference of squares here, but since 5 is not a perfect square, this is the best I can do.
So when we put this in on certified, do we need to do the bracket or the parentheses?
Parentheses. I don't think there is actually a bracket on this thing. I just did that to emphasize that I'm pulling out the x plus 2, and then this is holding what's left over. So, but bracket in mathematics, bracket and parentheses are the same thing. It's just that I have a different set of parentheses. If I use parentheses, people get confused on which one's which. So if I switch them up and use pointing brackets, so I use a different set of, bunch of different kind of brackets. there's the parenthesis bracket, there's the bracket, there's the pointy bracket, and then I can start making stuff up with bold brackets and all kinds of stuff if I'm trying to emphasize open, close, that type of thing. But usually we just use parenthesis, parenthesis, parenthesis. But when you do that, like on computers, you know, you open 3 of them, you've got to close 3 of them, and if you forget to do that, you get an error message, that type of thing. Question? What's that now? Why is the x being squared? Okay, so on this particular, on this one right here, okay, on this one, I've grouped the first 2 guys together. X cubed plus 3x squared, right? So on this particular problem, what do you got in common? I had an x in common. So I pulled out, and I'm sorry, I had an x squared in common, right? I got x cubed, I got 3 of them, I got x squared, I got 2 of them. I have an x squared in common, right? So if I pull out an x squared out of an x cubed, what's left over? X, one more x. And when I pull the x squared out of an x squared, that's completely gone, I'm left with the 3. Now on this one, I got minus 5x minus 15. They both have a 5, and they have that negative in common, so I factored out the negative 5. When I pull a negative 5 out of a negative 5x, leaves me with an x. When I pull a negative 5 out of a negative 15, it leaves me with a plus 3. Factoring means divide. And now I'm looking at these 2 terms. I pulled out the x plus 3's, and I'm left with, from the first term, the x squared, and that sign right there, from the second term, I'm left with a minus 5. Okay? Try this one here. X cubed plus 2x squared minus 9x minus 18. 1, I don't have anything in common in every term. Second, it's 4 terms. So I'm going to try the factor by grouping technique because of the 4 terms. That's your kind of your key there. So, what do you got in common on the first 2 terms? It's like an x cubed and a 2x squared. What's in common? X squared. What are you left with? X plus 2. Now I've got a minus 9x minus 18. What have I got in common? Negative 9. Factor the negative 9 out. What are you left with? X, and take a negative 9 out of a negative 18. I'm left with a plus 2. Does that make sense? Now I went from 4 terms down to 2 terms. Terms are separated by pluses and minuses, a big minus in the middle. What do you got in common? X plus 2. Now once I pull out the x plus 2, what are you left with this first term? X squared. And when I pull the x plus 2 out of the minus 9 times x plus 2, I'm left with the minus 9. Now here's the deal. This particular problem here, I'm not done. See, the difference between this problem and this problem is that I got x squared minus 9. What exactly is 9? 3 squared. This one really is a difference of squares, right? So how does x squared minus 9 factor? You can continue factoring it until you can't factor it anymore. This is what the computer wants. X plus 2 times, how does x squared minus 9 factor? X plus 3 times x minus 3. And that factored completely. Question? Yeah?
What would you do for a problem that had a commonality through the whole line, through the whole string?
What do you mean? Did not have a commonality? Or did have a common thing?
Like you see how at first you said the first thing you notice is there's something common in all the terms.
Yeah.
What if there was something common in all of the terms?
Oh, sure, I can make up one of those. All right, try this one. 3x cubed plus 9x squared minus, hold on, I gotta do the math here. X minus 36. All right, I just made this one up. Let's try this one. Want you to factor 3x cubed plus 9x squared minus 12x minus 36. Now, I made it up at the top of my head, so it probably won't work. But let's try it out anyway. First things first, look at this particular polynomial. What do you notice before I mean, the word is factor. That's all they're going to tell you on this thing. Yeah, you're right. I see 4 terms. But before I try to do the factor by grouping method, I also notice this. 3x cubed plus 9x squared minus 12x minus 36. They have a factor of 3 in common. And if it's in every term, if they want me to factor, first pull that kind of stuff out. So I'm going to pull out the 3 first. That leaves me with x cubed plus 3x squared minus what? 4x minus 12. 3 times 12 is 36. Thank you. Yes, 12 minus 12. Does that make sense? Now, I'm going to leave that 3 out front and now do the factor by grouping stuff. And put a big parenthesis there, or a bracket if you will. Just leave the 3 out front and don't worry about him. He's now part of the answer. What do you got in common on x cubed plus 3x squared? X squared. And when I do, I got an x plus 3 in common. Now, what do you got in common on the minus 4x minus 12? Minus 4. You got a minus 4 in common. So when I factor that out of the minus 4x minus 12, what am I left with? Minus 4 out of minus 4x leaves me with x. A minus 4 out of a minus 12 leaves me with a plus 3. Does that make sense? Keep that 3 in common. And now I'm going to factor between these terms. I can pull out the x plus 3. And that would leave me with x squared minus 4. You with me? And now I can drop these set of brackets because now I have parentheses, but I notice something real special. How does x squared minus 4? I can factor that guy some. That's a difference of squares, so my real answer is going to be 3 times x plus 3 times x plus 2 times x minus 2 for the difference of squares. And there is my final solution. If you got something in common, go ahead and pull him out first and then try all the other techniques. Does that make sense? Yes, ma'am.
Would it still work if you didn't take out the 3 at the beginning? Or would come up with the same answer?
You can, but you just have to factor the 3 out later. And if you do that, you'll still come up with the same answer. But if you forget to factor out the 3, the computer's going to count it wrong. Okay, so if you see it in common, it makes smaller numbers, less chance to screw it up. Yes, ma'am?
Does the 3 go away?
No? Okay, now understand, this is not an equation. This is just simplified. Now, if I set it equal to 0, which is probably what you're thinking about, then you're going to set each factor that has an x in it equal to 0, because this is eventually where we're going with this stuff. And since the 3 doesn't have a factor, it would, quote, go away, and I'm sure that's what you're thinking of. So you only focus on this. But in terms of simplifying it, the 3 was up there originally. This is all equal, equal, equal. The 3 is there, it just doesn't have an x in it. Yes, ma'am?
So are there problems like number 15 and the one that you just made get how do you check them to make sure that they get back to that first equation?
Exactly the way you think you should check them. If I wanted to check this thing, you know what you're going to have to do? One at a time. Take the x plus 2 times x minus 2. How would you clean that up? Fold it out, right? And when you clean it up, you get x squared minus 4. And then you're going to FOIL this thing out. And then you get something that looks like this. Then you distribute the 3, and you can walk your way right back to where you came from.
So it'll just work back.
It'll work backwards. It'll take you like 20 minutes, but it'll work backwards and stuff. Yeah, yeah. 'Cause these are much bigger problems. But yeah, folding it right back out is going to do the same trick. All right. Now let's take. Oh, sorry. Yes, ma'am. One more question. Yeah.
Okay, so if the second part is not a factor of 3, then would we still put the 3 out?
Okay. You're talking about in this thing right here. If this one or this term wasn't a factor of 3, then you would not pull the 3 out. You couldn't. To pull completely out, to factor it out, it has to be a factor of every term. And if it's not, you're back to doing a problem like this. You just group the first two guys together and pull what's in common, and the last two guys together, pull what's in common. And listen up, if it is a factor by grouping technique, then what's left over should be exactly the same. If it is not exactly the same, it doesn't factor. And there's lots of problems. I mean, if you actually try to make up one, chances are it won't factor. Most things in the world don't factor. These are very special problems that when I do the proper technique, they actually break into smaller terms. Okay? But I try to get you guys to understand the importance of factoring. Is this. All right, how many of you guys have had chemistry? Taking chemistry, high school or whatever here, chemistry. What's the whole idea behind chemistry? I mean, for example, what's water as a molecule? What is it? H2O. Everybody knows that. What does that mean, H2O? Two hydrogen what? Atoms and one oxygen atom. So if you wanted to break something big up, like water molecule, you break it into what? Atoms, right? And atoms are the smallest elements that you have that you can't break up anymore and still maintain the element. That's a hydrogen element. Once you start splitting the hydrogen element, what do you got? Boom, bombs. Okay, so don't split the hydrogen atom. That's called World War II and the bombs and stuff like that we make with nuclear bombs and stuff. So the smallest element you can have is an atom. This is what you're studying in chemistry. When you're doing factoring, you are taking some big, in this case, polynomial, and you're breaking it down into all the things that multiply that make up that polynomial. These are the atoms of that big old molecule polynomial. That's the main idea that's what's going on that leads you into all this other science stuff. This is the mathematics behind it. But that's the main idea. It has so many links to so many different areas. But what factoring does is it breaks it down into the parts that make up the whole thing. Okay? Through multiplication. Now let's take a look at this guy here. I got 12x to the negative 3/4 plus 6x to the 1/4. These are tricks. Okay? We can still factor. But what's going to mess people up is these darn negative exponents. Okay? So I've got 12x to the negative 3/4 plus 6x to the 1/4. All right, we're going to factor. What's the main idea behind factoring? Pull out what's in common. What do we have in common? All right, let's focus on the numbers first before we get to the x part. What do I have in common? I got a 12 and a 6. What do you got in common? 6. I'm going to pull the 6 out. But now, here's the trick. I got x to the negative 3/4 and x to the positive 1/4. They're both x's. I have an x in common. Now, negative exponents really kind of mean it's on the bottom, but we're not going to go that trick to it. What the deal is this. You're going to factor also out x to that negative exponent. What's x to the negative exponent? X to the negative 3/4. Put a parenthesis, because when you pull that out, what exactly is factoring? It's dividing out, okay? Factoring is dividing out. But if I pull a 6 out of a 12, what am I left with? 2. If I pull the x to the negative 3/4 out of an x to negative 3/4, it's gone and I got 1 for placement, but 2 times 1 is 2. Plus, here we go. I've already pulled the 6 out, so it's gone, right? But now, what happens when I pull x to the negative 3/4 out of an x to the positive 1/4? When you factor, you were dividing out, right? What was the trick about exponents when you divide? When I divide and they're like bases, what do I get to do with the exponents? Subtract them. So this one was a 1/4, and I'm going to subtract what I'm pulling out. I'm going to subtract the negative 3/4, because that's what I was pulling out. What you factor out is what you're dividing out. When you divide with the like bases and the exponents, you subtract that exponent off of the guy you had. Does that make sense? Now let's clean them up. This will be 6x to the negative 3/4 times 2 plus, now help me out with these fractions here. What's 1/4 minus negative 3/4? A minus negative means it's a what? positive. What's 1/4 plus 3/4? 4/4 or 1. That's x to the first. Yes, ma'am.
Oh, wait.
How come you were able to pull out the negative 3/4 if it's not common?
Well, the x is in common, so the trick to make this stuff nice is to pull the x that has the negative exponent out, and it'll make this guy a much bigger positive exponent when you do, and hopefully he'll be nice, like x to the first. That's the trick.
You always pull out the negative.
Always pull out x to the negative exponent. Always pull out the negative exponent part.
Not a fraction two, you would pull out the negative.
Just pull out the negative exponent out of the guy. Yes, ma'am.
What if they're both negative exponents?
Pull out the bigger negative exponent.
By bigger,
Okay, bigger negative. You understand, when I talk about negative numbers, the bigger the negative, the smaller it is. You've got, 0 through a billion, an infinity type thing. But when you go on the negative side, -1 is smaller than 0. -2 is smaller than -1. So the bigger the negative number, by definition, the smaller it is. So you pull out the bigger negative number or the one that's smaller. Because that's the whole idea behind factoring. You're factoring out the smaller guy. The guy with the negative exponent is the smaller dude. Does that make sense?
yeah.
Okay.
Are we ever gonna encounter some that have, different denominators?
Well, I could do that to you. Probably not, but let me see. If you have different denominators, how do you add fractions or subtract fractions with different denominators? Okay, you're on your own then. Okay, I can do that now. Make sure I put that on the next test. But, all right, but you can have different denominators. You just have to go for the common denominator. Yeah, you can do that. All right, take a look at this guy here. Okay, questions? All right, so I got x squared plus 3 raised to the negative 2/3 power plus x squared plus 3 raised to the negative 5/3 power. Both negative. So they have an x squared plus 3 in common, but what am I going to factor out of this guy? What did I just tell you guys? When you have both negative exponents, and you want to factor it, which one are you going to factor? The bigger negative, which by definition makes them smaller, but the bigger negative one. Which one is bigger negative? X to the negative 5/3. So I'm going to factor out x squared plus 3 to the negative 5/3. And when I do that, that leaves me with this guy. It is x squared plus 3 to the negative 2/3. But when you factor out the negative 5/3, what do I get to do? So factoring out means I'm dividing it out, so that would be subtracting exponents. Minus the negative 5/3. Plus, what do I get when I have x squared plus 3 to the negative 5/3 and I factored it out? What do I have for placement right here when you pull out the whole darn thing? What do I get? 1 for placement, because when I distribute, I should be back to where I started from. But remember, when you factor out that negative exponent, it'll be the other dude, same dude, but you have to subtract because you're dividing out that negative exponent. Now let's clean it up. A minus a negative makes it a positive, so this is x squared plus 3 raised to the negative 5/3 times x squared plus 3, what? What is negative 2/3 minus negative 5/3? A minus negative makes it a what? A plus. What is negative 2/3 plus 5/3? Well, we rigged this just right. It's 3/3, right? Which is 1 plus 1. Just write it up here. Negative 2/3 minus negative makes it plus 5/3. And when you add fractions, I already have my common denominator. They're both over 3. So add up your numerator. Negative 2 plus 5 is 3. 3/3 is 1. What's anything raised to the first power? Itself. So this is equal to x squared plus 3 to the negative 5/3 times x squared plus 3 plus 1. Anything to the first power is himself. You always want to combine like terms with this stuff. And the like terms I got is 3 plus 1. So my answer is x squared plus 3 raised to the negative 5/3 times x squared plus 3 plus 1 is 4. And there is my solution. So when you're factoring and you've got negative exponents, you pull out the largest negative exponent, or which is the smallest guy. Yeah.
Where did you get the +1 in the first string?
All right, on this one right here. Remember, this was my original problem. I'm factoring out x squared plus 3 raised to negative 5/3. I'm factoring out this dude right here. So in this first one, when I factored out, it's the same base, so I just subtracted the negative 5/3, because when you factor, you're dividing out. Plus, when you factor out the entire thing, what do you always have for placement? This is what I factored out. So when I pull it out, I always have a 1 for placement. Always a 1 for placement. You gotta, when you factor out, you always, and everything goes, you always have +1.
Division, so it ends up as 1.
Right. All right. Let's take a look at section 2.1.
Mr. Taylor,
Yeah,
1.5, what quiz is that?
I believe that is, a 1.5 is quiz 5. Okay, let's see here. Let's do the math. We started out with, hold on, I can tell you very quickly. What was the first section we started? Let me get my, here it is. All right. All right. 1.3, I'll blow this up so you guys can read it. 1.3 was quiz 1. 1.4 is quiz 2. 1.5 is quiz 3. 1.6, 2.1 is quiz 4. 2.2 will be quiz 5. Does that make sense? All right, so your question was, which one's quiz 5? 2.2. They're in order of the sections that we cover. So, there you go. All right, now, all that factoring just did, now you know why it's important. Section 2.1 is we're going to go solve for x. Now, understand, I'm changing the rules here. The last several sections, I've been just simplifying, combining like terms, reducing it, factoring it, whatever the case may be. But all I got is one side of an equation. It's not an equation, it's an expression. We're just trying to make it look good. That's called simplify. Now we have an equation. And the most important concept of solving for an equation is because you have two sides, one of the equal sign. What I do to one side of an equation, I have to do to the other side of the equation to maintain balance and maintain equality. So, solving something like this, and I'll set you up a problem here. I got 3x minus 9 equals 0. Now, I tried a simple problem here, but just to practice the steps involved in this thing. I got 3x minus 9 equals 0. How do you solve for x? You got to get x by himself. So the first thing you want to do is move the non-x terms to the other side of the equation. So I have minus 9. So what do? I add 9 to both sides. And you'll notice that the minus 9 plus 9 cancels, and that leaves you with the 3x on the left, and 0 plus 9 is 9. I get 3x plus 9. To get the x by himself, you want to get rid of the coefficient in front. I have a 3 in front. What gets rid of times 3? Divide both sides by 3. The 3's end up canceling, and you get left with x equals 9 over 3. And of course, with all answers in this stuff, simplify it. 9 over 3 is 3. So, we'll start out easy, and as we go along, we'll just make them harder and harder and harder, because we are trying to approach this class as somewhat of a review, but getting you back in the right frame of mind before we start doing things like logarithms and exponentials and the more difficult concepts of this stuff, because you still see the same type of stuff all throughout the semester. All right, so I got 4x minus 3 equals 17. What's your first move to solve for x? All right, I want to get the x by himself, so the first move is I'm going to add 3. What I do to one side, I do to the other. That leaves me with 4x equals 17 plus 3 is 20. Now I got 4x equals 20. I want to get rid of the times 4. What gets rid of times 4? Divide by 4. And I get x equals 20 divided by 4 is 5. And that's my solution. Of course, you can always go back and double check your answers. This is why everybody should make an A in college algebra, is because check your answers. Plug back into the original equation. X is 5. 4 times 5 is 20, minus 3 is 17. Yep, that pretty much is my answer. But of course, they try to make them harder by throwing a bunch of negatives and parentheses and brackets and all kinds of stuff. The goal here is to, when you're trying to solve an equation, the first move is to get rid of all parentheses. You get rid of parentheses by distributing, by multiplying, by the denominators, whatever you got to do, get rid of your parentheses so you can manipulate the terms. So the first move I would make here is distribute the negative inside my parentheses. I got the problem 2 minus 7x plus 5 equals 13 minus 3x. My first move is to get rid of parentheses. But the negative changes my sign, so what am I left with? 2 minus 7x what? Minus 5 equals 13 minus 3x. What's my next move? Always combine like terms. Trying to reduce it all along the way. Do you guys see anything that can combine? Yeah. What's 2 minus 5? So I got negative 7x minus 3 equals 13 minus 3x. Combine like terms. Now I'm going to juggle. Trying to solve for x, I want to get all the x's on one side. So my next move is I'm going to add 3x to both sides. It cancels on the right here. But what is negative 7x plus a 3x? Like terms, just add the coefficients. What do you get? Negative 4x minus 3 equals 13. Next move, get the x term by himself, add 3. This cancels, leaving me with negative 4x equals 13 plus 3 is 16. And then what's your last move to get the x by himself? Divide by negative 4. This cancels, leave me with x equals, what's positive 16 divided by negative 4? Negative 4. And there's my solution. But if you listen to my words, and I said this every time, what's your next move? What's your next move? Because doing algebra as we increase all the stuff we're doing is a game. It's a game where you have to know how to manipulate and how to do moves. It's just like a chess game or checkers or whatever game you guys play. But where most people will screw this problem up, they try to do too much stuff in their head. It's basically every move I make, it's like a new problem. And then I got to decide what I'm going to do. What am I going to do? What am I going to do? Yes, ma'am.
Does the answer for x amount to the value of 4? Because when you take the negative 7 minus 3 equals 13 minus 3x, can you add 7 and then make a positive 4?
Okay, no. Okay. You could do, there's more than one way to manipulate the equation. You're right. I could have added 7x over on this side and made a positive 4 over here. But then I would have subtracted the 13 over here and made on the left side negative 16. And so when I divided, I got negative 16 divided by a positive 4. You're still only going to get one answer. The answer is negative 4. But you could have juggled it differently to get a positive coefficient in front of the x, but it would have made the negative constant in that case, and you would have still gotten the same answer. So there's only one answer, but there's lots of different ways to get to that answer. All right, let's try the next one over here. Questions? All right. So next one, I got fractions. It didn't take me long to get into the fraction game here. But remember this. This is an equation with fractions. That's just different from me making you ask, what's 2/3 plus 7/8? That you have to go through the common denominator routine and try to get common denominators, all that stuff. I'm not doing that here because I have an equation. I got x minus 3 divided by 4 equals 5 divided by 14 minus x plus 5 divided by 7. The first move on when you have an equation equal to, right in the middle, that has fractions, your first move is get rid of parentheses and get rid of the fractions. That's the beauty of algebra with an equation. I don't just have to get a common denominator. I can actually eliminate denominators by figuring out what the common denominator is. Look at your denominators. I got a 4, a 14, and a 7. What is your common denominator? Personally, I like the lowest common denominator. Small numbers are always better, but I'll go with any denominator that'll work. What's the common denominator between 14, 7, and 4? What number that each one of these guys divides into? What is it? 28. You could also use 56 if you wanted to. That all of them divide into that too. But honestly, 28 is the lowest common denominator. So here's the deal. My common denominator is 28. I'm not going to go for a common denominator because I have an equation. Remember this. What I do to one side, I do to the other. What I do to one term, I do to all terms. Terms are separated by pluses and minuses. I've got this term equals this term minus this term. I'm going to multiply each term by 28. Times 28, times 28, times 28. Because it's a perfectly legal math move. What I do to one side, I do to the other. What I do to one term, I do to all terms. Now, it cleans up nicely. 4 goes into 28 how many times? 4 divides into 28 how many times? 7. So I'm left with a 7. What's your parentheses? It's 7 times the rest of the numerator, which is x minus 3, equals 14 goes into 28 how many times? Twice, 2. I'm left with 5 times 2. I did that for your benefit. Most people would have written 10. But I wanted you to see that's the numerator times what's left over. Minus, keep your sign there, 7 goes into 28 how many times? 4 times. And you're still left with that numerator x plus 5. Notice I put parentheses always around the numerators, and that sign stays out front. So now, get rid of your denominators, and back to now get rid of your parentheses. Here I'm going to distribute. 7 times x minus 3 is actually 7x minus 21 equals 5 times 2 is 10. Now this is a minus 4. Minus 4 times x plus 5 would be minus 4x. And minus 4 times a positive 5 is a minus 20. Now what's my next move? Always, always, always combine like terms. Anything that looks alike, go ahead and put them together. This is 7x minus 21 is equal to, well, let's see here. I got negative 4x, but I can combine. What is 10 minus 20? Negative 10. Now, most folks like to manipulate and juggle these equations such that my variable is always positive. You can juggle it to either side. If you want the variable to be positive, fine. So I'm going to try to get all my x's on one side. So to move across an equal to with terms, I'm going to add or subtract. I'm going to add 4x to both sides. On the right, it cancels. This leaves me with 7x plus 4x, which is 11x minus 21 equals negative 10. Now I'm going to add 21 to both sides to get the x by himself. 11x is equal to, what is negative 10 plus 21? 11, makes it nice. I made up these problems, so what's the answer? Divide by 11 on both sides and you get x equals 1. Does that make sense? And regardless of which side you manipulate it to, when you divide out, x will always be 1. Yes, ma'am?
So for the common denominator,
Yeah.
only multiply that by the denominator, not the whole.
You're multiplying the entire equation by your least common denominator, but what that entails is you multiply each term by that common denominator, which now eliminates all your fractions and leaves you with just numerator, the numbers from the numerator, and whatever's left over.
So your numerators would never really be affected by that.
Yes, my numerators are affected by what's left over. 4 goes into 28 7 times, and whatever's left over times the numerator. 7 times x minus 3. 14 goes into 28 2 times, so it's the numerator, 5 times that 2. And 7 goes into 28 4 times, so it's that 4 times x plus 5 with that negative out front. Yes, ma'am?
So the denominator just disappears. And
The
then
denominator, you get rid of it by multiplying on both sides by that lowest common denominator. You're killing off your denominators, which makes the problem so much nicer to play
wouldn't
with.
that be just the denominator? Wouldn't it be like that second row is over 28?
If you got a common denominator, You can put it over 28, sure. Then multiply both sides by 28, and the 28's all cancel. So you're doing that all in one fell swoop. And the goal here is to make the problems easier. And when it comes to fractions, getting rid of the denominators makes fractions so much better because you have no more fractions. It's all numerator stuff. Try this guy here. I've got 4/5 times n minus 10 equals negative 8/9. All right. Now, there's two different ways you could do this problem, and it's really up to you. But personally, I am of the rule of thumb that the first thing that I want to do is, if possible, get rid of parentheses. So it's a fraction. So what? I got 4/5 times n minus 10. I want to get rid of parentheses here. How do I get rid of parentheses? I'm going to distribute. Don't worry, I'm going to get rid of denominators too. Those fractions bother me just as much as they bother you. But first thing I'm going to do is get rid of the parentheses. What's 4/5 times n? 4/5 n minus, what's 4/5 times 10? Well, we can go ahead and clean that up. 5 goes into 10 how many times? 2 times the numerator 4 makes it 8 equals negative 8/9. Does that make sense? I distributed the 4/5. And 4/5 times that negative 10 is where the negative 8 came from. Now, I've got terms. Terms are separated by pluses and minuses. Now, I'm going to analyze the denominators. What's the denominator on the 4/5 n? 5. What's the denominator on the 8? Understood to be 1. It's still a fraction. And what's the denominator on the negative 8/9? The 9. Look at your denominators. It's 5 and a 9. What is my least common denominator that's a bigger number that both these two numbers divide into? 45. So what I do to one side, I do to the other. What I do to one term, I do to all terms. I'm going to multiply every term by 45. And I got 45 by taking the 5 times the 9. So times 45. So 5 goes into 45 how many times? 9, and I'm left with still my numerator, 4n, minus 8 times 45. I'll just write it as 8 times 45 because nothing canceled there. Equals 9 goes into 45 how many times? 5. I'm left with a negative 8 times 5. Now, you don't have to go through this elaborate. I do want you guys to do math in your head, but I'm writing it out to show you, to answer your question, that your denominators cancel, so it's what's left over times whatever the numerator's in there. What is 9 times 4n? 36n minus what is 8 times 45? 360 equals what's negative 8 times 5? Negative 40. Now it's just bigger number, linear equation. I want to get the n by himself, so I'm going to add 360 to both sides. That's 36n is equal to, what is negative 40 plus 360? 320, right? What's your last move to declare victory on this problem? To get the n by himself, you're going to divide by the coefficient, 36 on both sides. That cancels, and I'm left with n is equal to 320 divided by 36, which is, it reduces to 89ths. You guys get that? I did it on the calculator. I cheated. All right, 320, because it's a big number, divided by 36. It gives me 8 and 8/9. There, 8.8888. And all I did was math, convert it to a fraction, and I got 80 over 9. So yes, you can still have fractional answers. Don't freak out about that. Yes, ma'am.
Didn't you just have, add, was that at the first step, added 8 and then go to the other side and added by 36?
Added the 8s. Wait a minute, I could have added this guy over here. This one here. I could have added 8 over here with the negative 8/9. You're right. But now what's 8? What is negative 8/9 plus 8? 7 and 1/9. Oh, it's still crappy fractions. So once I got rid of parentheses, I can get rid of the denominator and no more parentheses, less chance for careless error. study hard on this stuff, and I'll see you guys next time.